So we discussed the electrolysis of molten lead to bromide, and we discussed the molten sodium chloride. Now we'll discuss for aqueous substances. So electrolysis of aqueous substances. Like if we have aqueous substance means that it contain water. Then the aqueous substances are divided into two categories. It can be a concentrated aqueous solution, or it can be a dilute aqueous solution. So what is the difference between the concentrated aqueous solution and dilute aqueous solution? The term concentrated aqueous solution means that it contains more salt and it contains less water, a small amount of water and more. Like when we compare the proportion, the number of the particle, there are more salt particles and there are very few water particles. So we call that is the aqueous solution because water is there. But comparison, the water molecules are small, little number of water molecules. So we call that as a concentrated aqueous solution. But what is the meaning of dilute aqueous solution? Dilute aqueous solution means we'll have less salt and we'll have more water or more water molecules. Example, if I say I have 100 molecules of sodium chloride and I have only 10 molecules of water. Which kind of mixture is this? Concentrated or dilute? I have 100 molecules of the salt and I have only 10 molecules of water. Which kind of mixture is this? So it is a concentrated solution, a concentrated mixture. But if we have, example, only 10 molecules of sodium chloride and we have 200 molecules of water, what kind of mixture is this? Few molecules of salt and more molecules of water. So we call that mixture as a dilute mixture. So an aqueous solution can be a concentrated, an aqueous solution can be a dilute. So it depends on, because the electrolysis of aqueous solution divided into two categories, because when we have a concentrated solution we have different products, and when we have a dilute solution we have a different products. So now we'll do for each, like starting with electrolysis of concentrated aqueous concentrated sodium chloride. So we have aqueous concentrated sodium chloride. What does it mean? We have more sodium chloride and we have less water molecules. As it is mentioned, it is aqueous concentrated, so more salt and less water. and we are using the same electrode, using the inert electrode. So the electrodes are made up of carbon, graphite, or we can say platinum. Because we break them into, when we dissolve the ion, the substance will dissociate or break down into ions. So what will be the ions present in the mixture? It is sodium chloride and water. Aqueous means water is there, and sodium chloride is NaCl. So what are the ions present in sodium chloride? There will be a sodium ion, there will be a chloride ion. And aqueous means water is there, and what are the ions? When water dissociate, the water will dissociate into H plus ion and OH minus ion. This is a breakdown of water. Whenever the water break down into ions during electrolysis, it will dissociate or break down into H positive and OH negative. So these are the ions which are present in the solution of aqueous concentrated sodium chloride. The positive terminal electrode is known as anode and the negative electrode is known as cathode. Now what happened? The same way it works, we have a positive and negative terminal. So from the negative terminal, electrons are coming out. So majority of the electrons will be here. So what are the ions attracted towards the positive, towards the cathode? So positive ions are attracted. Why there is OH ion? As you can see, we have water. Water is H2O. So when water break down into ion, water dissociate into ion. So it dissociate into H plus ion and OH minus ion. This is how the water break down into ions. When we are passing a current, like you will find a person is getting sometime a person might get an electric shock due to a moist or wet condition. That is mainly due to the water molecule break into ion, and ions can conduct electricity. That's why a person is getting an electric shock. So the positive ions are attracted towards cathode. But the problem here, how many positive ions are there? There is a sodium ion and there is hydrogen ion. So both ions are actually attracted towards the cathode. Sodium ion is attracted, hydrogen ion is also attracted, but which ion will discharge or which ion will not, both of them cannot convert into atom, because one of the ion can move easily compared to other. So the positive ion which is less reactive will move easily towards the cathode. So this is a very important statement. When you have two positive ions, both ions will not move towards cathode. The positive ion, which is less reactive, will move towards the cathode. And to identify which positive ion is less reactive or more reactive, you have to memorize or learn a reactivity series. So you have to learn a reactivity series of the metal. You can learn from this sentence. I will write first the reactivity series of the metal and then I will use the sentence. So you have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, hydrogen, copper, mercury, silver, gold, and platinum. Normally, gold reactions throughout the O levels, you will not study any gold reaction, so you don't have to include gold. You will just include silver and platinum. But gold is also there. There are different reactivity series. This is a reactivity series which you have to learn or memorize according to your course outline. So potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and platinum. And as we go down the series, as we go down, the reactivity is decreasing. And how to learn this reactivity series, you will learn from this sentence that please send cat, monkey, and zebra in large high cage. Make sure pets locked. So using this, you will learn or memorize this reactivity series. The first letters are actually representing the name of the elements. So please send cat, monkey, and zebra in large high cage. Make sure pets locked. So P is representing what? Potassium. S is representing what? Sodium. Ca is representing what? Calcium. Cat. M is representing magnesium. A is representing aluminium. Z is representing zinc. I is representing iron. Iron symbol is Fe, but the name of element is iron. L is representing lead. Symbol is Pb. H is representing hydrogen. H. C is representing copper. Cu. Symbol is Cu. M is representing magnesium. Mercury. Magnesium is already there. This is representing mercury. S is representing silver. P is representing platinum. And the logged is just to complete a sentence. So it is please send cat, monkey, and zebra in large high cage. Make sure pet lock just to memorize this reactivity series. As we go down the series, as we go down in this series, what we observe the reactivity decreases. So now come back to the same, we were discussing electrolysis. So you have to learn or memorize this. Now, as we return back to this main topic, which is about electrolysis of aqueous concentrated sodium chloride. So as electron move from negative terminal of the battery towards the cathode, the positive ions are attracted, both positive ions are attracted, but the positive ion which is less reactive will move easily towards cathode. So which positive ion is less reactive, sodium or hydrogen? Can you identify which is less reactive, sodium or hydrogen? Which positive ion is less reactive here? This reactivity series you have to learn or memorize. So hydrogen is there, which is less reactive. So what happened here? The hydrogen ions are less reactive. So it will move towards the cathode. And now what will be the equation for hydrogen? Equation at cathode, the half equation. So the half equation for cathode, as hydrogen ions are moving there, as these hydrogen ions move, they will turn into hydrogen atom. So how many electrons this hydrogen ion should gain to turn back into atom? How many electrons this hydrogen ion should gain to turn back into atom? So it is plus 1. If it is written plus 1, it should gain 1 electron. So this because the charge on that represent the number of electron gain. So if it is plus 1, it should gain 1 electron and change into hydrogen atom. But hydrogen is a non-metal. So if it is a non-metal, when two hydrogen ions are there, they will gain 2 electrons and it will turn into a hydrogen gas. So hydrogen atoms which are produced here, the two hydrogen atoms which are produced here join together and it will form hydrogen gas. And hydrogen is also a colorless gas. So what is the observation? So observation is bubbles, or you can mention the colorless gas. So this is what we observe when a hydrogen gas is given off. And because it is gaining electron, so this change is known as reduction. Is it clear what happened at cathode, how we form an equation? So whenever we have two ions, two positive ions, so the positive ion which is less reactive will move easily towards cathode. That's why in this case hydrogen is less reactive, so it will move towards cathode, and this result in a formation of hydrogen gas. Is it clear? Abdullah Khan, Afreen, Basira, Heather. The term reduction and oxidation refers to, reduction means gain of electron. This is a term which is used to gain when something gain electron, we call reduction. So you can see the hydrogen ions are taking the electron and they're turning into hydrogen molecule. That's why we call this change as reduction. So whenever you have two positive ions, so in a molten, we don't have to check a reactivity, but in aqueous substance, we have to check the reactivity, because in aqueous substances, we have two positive ions. So the positive ion, which is less reactive, will move easily towards the cathode. Now, what happened? The negative ions are attracted towards anode. So as the negative ions are attracted towards the anode, what are the negative ions? Chlorine is a negative ion and hydroxide OH is a negative ion. But how to identify which negative ion will move? So the negative ion which is more in the solution will move towards anode. So the negative ion which is more in the solution will move towards anode. So which negative ion is more in the solution? As we know, it is aqueous concentrated sodium chloride. So sodium chloride is more, or chloride ion is more, and hydroxide ion is less. Why? Because it is mentioned here in the beginning, I mentioned it is the electrolysis of concentrated sodium chloride. So concentrated sodium chloride means less water, or less water means less OH ion, and more salt is there. So more salt means more sodium ions and more chloride ion. So when we check the negative ions, for a negative ions which are more in the solution will move towards anode. So in this example, which ions will move towards anode? So the chloride ion will move towards anode. So as the chloride ion will move towards anode, because they are more in the solution. So for positive ion, we check the reactivity, the movement of the positive ion, we check the reactivity, and for the negative ion, we check the amount. And how to write the half equation for anode? So the half equation for anode, the chloride ion, as they move, because it is written minus E, so will minus 1 charge is there on chloride ion, so it will be minus E, and it turned into chlorine atom. So chloride ion loses 1 electron and change into chlorine atom. But because chlorine is a non-metal, so when two chloride ions are there, they will lose 2 electrons and it will turn into chlorine. Is it clear, this part? And what will be the observation? The observation, what we will see, because chlorine is a gas, so we'll see bubbles, or it is a yellowish green gas. So bubbles will be there, either there will be bubbles or either there will be a yellowish green. You can write any one of them, bubbles or yellowish green gas. So this is what happened during electrolysis of aqueous concentrated sodium chloride. So I will repeat, look what happened. We have aqueous concentrated sodium chloride. So when we have aqueous solution, it means we have two ions are present. Because it is concentrated means it contains more sodium chloride, more sodium and chloride ion, and it contains less hydrogen and hydroxide ion. Because it is concentrated solution means more salt, less water. When we switch on the supply, the electrons move towards the cathode, and these electrons attract the positive ion, so they are attracting both sodium and hydrogen ion. There is attraction, but which ion will move? So the positive ion, which is less reactive, will move towards the cathode. So which positive ion is less reactive here? You have to learn a reactivity series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, hydrogen, iron, lead, hydrogen, copper, mercury, silver, and platinum. So you are having, in the solution, you are having a sodium ion and you have a hydrogen ion. So which ion will move towards the cathode? Always the less reactive. So when you check the less reactive ion position in the reactivity, you will find hydrogen is less reactive. compared to that of sodium. So that's why the hydrogen ion, which is less reactive, it is able to move easily. So when this hydrogen ion is able to move easily towards the cathode, it will turn into a hydrogen molecule. So we'll observe bubbles or a colorless gas. And this change is called a reduction because it is a gain of electron. For positive ion, we are checking a reactivity, and for negative ion, we are checking the amount. So we don't have to compare hydrogen with chlorine. Why we don't have to compare hydrogen with chlorine? Because hydrogen is a positive ion and chlorine is a negative ion. So there is no comparison of the reactivity between hydrogen and chlorine. So for what we do, we have a positive ion, so we have sodium ion and we have hydrogen ion. So the ion which is less reactive will move. So which ion will move here? The hydrogen ion will move towards. How we know which element is positive and which one is negative? You can use a periodic table for that. Simply using a periodic table, you can work out when you check sodium, it belongs to group 1, so it will be plus 1. Chlorine belongs to group 7, it will be minus 1. And for water, you have to just learn it contains H and OH ions are present inside the water. So sodium ions are and hydrogen ion are positive. So the positive ions are attracted towards the cathode, but the ion which is less reactive is able to move easily. So hydrogen ion is able to move easily. When hydrogen ion gain electron, it turn into a hydrogen gas. So we'll see bubbles or a colorless gas. For the negative ions, the criteria is not the reactivity, the negative ion, the criteria is the amount. So when you see in the beginning, it is written electrolysis of concentrated solution. So concentrated solution means it contains less water and it contains more salt. So less water means there are less OH ions and there are more Cl ions. So the ions which are more in the solution, the negative ions which are more in the solution will move towards the anode and it will lose their electron, they will lose their electron and turn into a gas. So chloride ion two chloride ions loses 2 electron and turn into a chlorine molecule. What is the observation when chlorine gas is there? You can say bubbles or you can say a yellowish green gas. Is it clear till this part? The electrolysis of aqueous substance. So for positive ion, you have to check reactivity. So simple rule is there for discharge of the positive ion. You will check reactivity. And for negative ions, you will check the amount. So when you check the reactivity, the positive ion, which is less reactive, will move towards cathode. This is for positive ion which is less reactive because there will in an aqueous solution there are always two positive ions, so the positive ion which is less reactive will move towards cathode and the negative ion which is more in the solution will move towards anode. So for negative ion, which is more in the solution, will move towards anode, and for positive ion, the ion which is less reactive will move towards cathode. That's a criteria for the movement of ions. Now I will give some examples. I just want you to recognize the ions and state which one will move towards anode and which one will move towards cathode. I'm starting with the same example. We have aqueous, concentrated sodium chloride. So if you recognize the ions first, so first, what are the ions in aqueous sodium chloride? It contains sodium ion. Group 1 is there, so it will be +1 ion. Chlorine is group 7, -1. And it contains, whenever term aqueous is there, it means water is also there. And what are the ions of the water? So it contains H ion and OH ion. Okay. This is first thing. The first thing, you will recognize the ions. Then for positive ion, there's different criteria. And for negative ion, there is a different criteria. Now for positive ion, what is the criteria? The criteria is less reactive. So which one is less reactive here for positive ion? Sodium ion or hydrogen ion? When you check the reactivity, so hydrogen ions are less reactive. So hydrogen ion will move towards cathode. Why they are able to move towards the cathode? Because less reactive means they are not able to react with anything. So if they are not able to react with any substance, they can easily move. Sodium ions are more reactive, so they stick with other ions, or they tend to react with other ions. So whenever a positive ion is there, the less reactive. Why they are less reactive? Because reactivity means tendency to lose electron. Sodium is bigger in size. Yeah, what makes them less reactive? When you compare the size, Abdullah, when you compare the size of sodium, sodium is having more shells as compared to hydrogen. So sodium can lose this electron easily because electron is far from the nucleus as compared to hydrogen. That's why if sodium can lose electron easily, it is more reactive. Reactivity of the metal means tendency to, or reactivity of element here for metal, it means tendency to lose electron. So for positive ion will move towards the cathode, and what happened? The negative ion, you will check the amount. So negative ion which is more in the solution will move. So this is aqueous concentrated. When we say concentrated, it means we have more salt and we have less water. So which ion will move? For negative ion, we check the amount. So chloride ions are negative, and where they will move? They will move towards the anode. So as these chloride ions move towards the anode, sodium ion move towards the hydrogen ion move towards cathode. So what we are left with, as you can see, when we are doing electrolysis of sodium aqueous concentrated sodium chloride, so hydrogen ions are removed, chloride ions are removed. So what we are left with? We are left with sodium hydroxide. So what happened to electrolyte? The electrolyte will turn into NaOH because sodium ions are hydrogen ions are removed, chloride ions are removed, so you're left with sodium ion and hydroxide ion. So the electrolyte will turn into sodium hydroxide. They are attracted, there is attraction, but they are not able to discharge. there is attraction. It's not like, I'm not saying there's no attraction. There is attraction between the sodium ion and the cathode, but because hydrogen ion move easily, move faster, unreactive, so they go there first and they're released out as compared to that of sodium. And because chloride ion are more there, so greater amount, that's why they're able to move quickly. So whenever we are doing electrolysis of aqueous concentrated sodium chloride, the hydrogen ions move towards cathode, chloride ion move towards anode. On what happened to the electrolyte? What will be the change in electrolyte means what we are left with? We are left with sodium ion and hydroxide ion. So the electrolyte will turn into sodium hydroxide. Is it clear? This electrolysis. So whenever you're doing the electrolysis of aqueous solutions, for positive ion, you will check the reactivity. For negative ion, you will check the amount. So tomorrow, means the next session, we'll do more examples related to electrolysis of aqueous substances. So today we did electrolysis of molten sodium chloride and we did electrolysis of aqueous concentrated. We did this, we did lead to bromide, as well as we completed the electrolysis of sodium chloride, molten. So in a molten substance, when you have a molten, you don't have to check the reactivity, because in the molten, if I say molten sodium chloride, so molten sodium chloride only contain one positive ion and one negative. That's why the sodium ion was moving towards cathode and chloride ion was moving towards anode. But if I say I have concentrated sodium chloride solution, aqueous concentrated, so there are ions present. There are two positive ions and two negative. One is sodium chloride, sodium positive, chloride negative, and due to water, H positive and OH negative. So the two positive ions, both of them are attracted, but one of them is able to change. And which one will be changed? The one which is less reactive. And for chloride and hydroxide ion, both are attracted, but the ion which is less, the ion which is more in the solution will move. So that's why the chloride ion will move. And we are left with sodium hydroxide. So in the next session, I will discuss more examples related to this electrolysis of aqueous substances. Any question or a doubt related to the class today? So I'll end the session and share this with you.